Hello everyone. Today let's solve the problem number 143, reorder list, right? So what the question states here, we are given the head of the singly linked list, right? So we are given the head of the singly linked list. So the list can be represented as L0, L1 to Ln minus 1 Ln, right? So here 1, 2, 3, 4 they have given in this case, right? Let's come to the example one. So here they have asked us to reorder the list to be in the form of following form. L0 Ln means the first element, the second element. L1 Ln minus 1 means the second element, the second last element. This one here in this case, right? So here first element, last element. L0 Ln. L1 Ln minus 1 means the second element, the second last element. Means like that it follows, right? Like that it follows, right? L2 Ln minus 2. If it depends on how many number of elements or how many number of nodes are present in the singular linked list, right? So this is fine. I hope the question is completely clear. They have clearly mentioned in the question the order that we have to return in the form of output, right? So here in this case, let's come to the first example. Here in this case, we have 1, 2, 3, 4. Head equals 1, 2, 3, 4. See, we have to order in this way. First element, last element, 1, 4, right? So the second element, the second last element, nothing but in this case 2, 3. So this one we need to return in the form of output. See here the output, that's what they have written here, 1, 4, 2, 3. I hope this is clear, easy to understand, right? Let's come to the second example here. They have clearly mentioned in the question as well, right? So I mean figure as well, the diagram that they have given here, this one I'm speaking of. So here in this case we have 5 elements or 5 nodes here, 1, 2, 3, 4, 5. First one and the last element, 1, 5. Second one and the second last element here, 2, this one and 4, right? 1, 5, 2, 4. And we have only single element left now, that we will append this one here. So this will be 1, 5, 2, 4, 3, right? 1, 4, 1, 5, 2, 4, 3. 1, 5, 2, 4, 3 is the output that we need to return. That's what they have given in the output as well, right? So I hope this is completely clear. So I hope this is completely clear. I mean they have given us wonderful examples, right? Just for the understanding purpose. So here I hope the question is completely clear. What we need to do is completely clear as right. So first let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially let's discuss the approach first. So let's discuss the approach step by step. The first thing that we need to keep in mind here is we will be going with a 2-pointer and in place ordering. So when I said in place ordering, you have already guessed that one, the space complexity would be because 1, because we are going with the in place ordering, reordering, right? So we are modifying in place. So we will be modifying the nodes in place, right? So we will be going with the 2 pointers and in place ordering, right? So the first example I have considered the first example that they have given in the question, so that it will be easier to understand. We have already discussed this one, right? So order they have given here is this one, first element, last element, 1, 4, and second element, second last element, in this case 2, 3. So that's what we need to return in the form of output. You can clearly see here 1, 4, 2, 3, right? So let's see the step-by-step execution here in this case, right? Let's see the step-by-step execution here. Head equals 1, 2, 3, 4 we have, head equals 1, 2, 3, 4 we have. This is fine. So the first case here, the first one or the first step here, we have to find the middle of the list. Means we have to find the middle of the list. Middle of the list means here in this case slow will stop at 2. So we will be making use of the 2 pointers. One is slow and another one is this one fast, or you can consider any this one. So slow will stop at, so let me go with slow and fast here in this case. So we have to first we have to find the middle of the list. What we will do, slow will stop at 2 here in this case. Slow will stop at 2. List is split into 1, 2 and 3, 4. We are splitting the list into 1, 2 and 3, 4. First we will stop the slow at 2 and list is split into 1, 2 and 3, 4. Why? Because we have to find the middle of the list first. So we will reverse the second half. So we will reverse the second half. Means first half is this one, 1, 2, and the second half is this one, right? So this one is first half, this one is second half. When we reverse this one second half, 3, 4 becomes 4, 3. That's what I have written. Don't get confused here. So we will split the list into 1 comma 2 and 3 comma 4. We will split the second list, right? So we will split the second half, or the second half itself, sorry, 4 to 3, right? So it will be 4 comma 3. So now if we merge, what we have here, 1 2 3 4 comma 3. Now when we merge, it will be 1 4. This will be like this, 1 2 4 comma 3, right? When we merge, it will be 1 4 2 and 3, quite obviously 1 4 2 and 3. So when we merge here, that's what I have written here, 1 4 2 3. When we merge, this will become 1 4 2 3, right? First what we will do, we will split the, accordingly, first we will find the middle element. So we will split the list into 2, 1 4 2 and sorry, so here I got confused, just give me a second here. 1 2 3 and 4, right? 1 2 4 and 3, 1 2 4 and 3. When we split this one, second half, we will swap the elements, right? This will become 1 comma 2 and 3 comma 4. Now we have, sorry, 3 comma 4, 1 comma 2, not 3 comma 4 we have. So we have 3 comma 4. Now we will, after this one 3 comma 4, what we will do, we will swap the elements here. This becomes 4 comma 3, second half, right? So we'll swap the elements in the second half, this one 4 comma 3. Then we have 1 comma 2 4 comma 3. Now what we will do, we will merge this one 1 comma 4 and 2 comma 3. So this will become 1 comma 4 2 comma 3. Again I have explained the same thing, so this is fine. So this is how we got 1 4 2 3. The final output here is within the array, but within the list, this one 1 comma 4 comma 2 comma 3. So this is equivalent to the output that they have given for the this one for the example 1 and the question 1 4 2 3. So the output that we have got matches the output that they have given for the example 1. So the approach works absolutely correct in this case. Our approach is completely correct, right? So now we are completely familiar with the approach. As we are familiar with the approach, let's discuss the edge cases quickly. So the first edge case here is for the single node. So for the single node, we have only one node here, so the output will be quite obviously 1 here in this case, right? So why the output is 1 here? No changes are needed because we have only one node, or the single node. So let's move on with the second edge case here, 2 nodes. We have 2 nodes, 1 comma 2 here. So no interleaving is possible here because we have only 2 nodes here in this case. So output will be quite obviously 1 comma 2 itself in this case, right? So simple to understand. Let's move on with the third edge case here, 3 nodes, 1 2 3 we have output. So this one will be middle, 1 comma 2 we will do 1 comma 2 and 3. So this will be 1 3 and 2 when we merge, right? So quite obviously you can just try it in the same way that I had explained, right? You can try it out in the same way that I had explained by considering first example, if you want to understand how we got this one, right? Accordingly with the approach, if you want to understand how we got this one, right? 1 3 2, this is fine. Let's move on with the fourth edge case, even number of nodes. We have even number of nodes here, 1 2 3 4, 4 nodes we have right here. So first element, last element, 1 4 2 3, right? 1 4 2 3, this is fine. So let's move on with the final edge case, or the fifth edge case here, odd number of nodes, means 5 elements here, 1 2 3 4 5. In this case 1 5 2 4 then 3, 1 5 2 4 3 here in this case, right? So these are the 5 edge cases that we need to keep in mind. These are the 5 edge cases that we need to keep in mind, right? First one is for single node, second one is for 2 nodes, third one is for 3 nodes, fourth one is for even number of nodes, and fifth one is for odd number of nodes. These are the 5 edge cases that we need to keep in mind. So one more thing I want to explain here. So now we are that is not required, leave anyway. So here anyways we are completely familiar with the approach and edge cases now. So as we are familiar with the edge cases and approach, it will be easier to write the code. Now let's start writing the. So the first step here is, we know that we have discussed this one in the edge case. So if the list is empty or has only one node, we need to there is no need to reorder. So we have discussed this one multiple times also in the edge case we have considered, right? During the edge cases while discussing the edge cases, if the list is empty or has only one node, then we don't need to reorder. I mean no need of reorder, right? So here we don't have to reorder, sorry. So This is fine. So I'll just write that one in the form of code here. If head equals null or head dot next, this is equal to null, then there is no need to reorder at all. So I'll just I'll not return anything here on this case, right? This is fine. Let's move on with the first step. We have to find the middle of the linked list using the slow and fast pointers. This we have discussed during the approach by considering the first example. So I'll just articulate the same thing in the form of code quickly. So let's write here list node slow and fast pointers we are considering right here. Head and fast also, let me initialize this one to the head, both slow and fast pointers. So first thing, I'll just consider the while loop here. While fast not equal to null and fast dot next not equal to null. In this case, what I'll do, slow moves one step and the fast moves two steps here. Slow equals slow dot next and fast equals fast dot next dot next. This is fine. Now we know this one, right? So we are familiar with this one. We have already solved this one. I mean, this is nothing but tortoise and hare algorithm, right? So for the cycle detection purpose, so we have done the similar thing. So we know this one. So we are finding the middle of the linked list using the slow and fast pointers here on this case, right? This is fine. So the next step or the second step, if you remember during the approach, after finding the middle of the linked list using the slow and fast pointers, we have to reverse the second half of the list, right? So we had 1, 2, 3 and 4. I think the second half was 3 and 4. We reversed that one to 4 and 3. 4 and 3, right? 3 to 4 to we reversed or we swapped the elements, right? 1, 2, 3, 4 we had. Instead of 3, 4, when we swapped, we got 4, 3, right? That's what we have to reverse the second half of the list. So I'll just give here list node. Let me consider previous equals null here in this case. Current, let me assign this one to the slow dot next. This is fine. So we will split the list into two halves first. Before reversing the second half of the list, first thing is we will split the list into two halves, right? So I'll just give here slow dot next equals null. This is fine, simple to understand. So after this one, yeah, we will store the next node. We will reverse the current node's pointer. We will move the previous to current, and finally we will move to the next node. So that is, we will reverse the second half of the list, right? So now we have successfully split the list into two halves, right? Next is we have to reverse the second half of the list. So for that, I'll just this one, make use of the while loop. Current should not be equal to null, right? Right? It should contain some node. So this one, I'll just consider list node here. Next temp here on this one, current dot next. This is fine. So the next step here is we will reverse the current node's pointer. So I'll just give here current dot next here. This one, let me assign this one to previous. Let's move previous to current, and also after moving the previous to current, let's move to the next node. I'll just give here previous equals current, and then let's move to the next node. Means let's move the current pointer to the next temp, right? So that's the variable name we have considered, next temp. So I'll just give here next temp. This is fine, simple to understand. Let's come to the final step or the step 3. So now we have successfully reversed the second half of the list. First step was this one. We have to find the middle of the linked list using the slow and pointer. Second step, we reverse the second half of the list. Third step, if you remember, we have to merge the two halves now. So 1, 4, this one, 1, 2, 4 and 3 we got. We split that one and we have swapped the elements in the second half. After that one, we have to merge them, right? 1, 4, 2, 3. The last one, the last step. So that's what we'll be doing here. So I'll just give here list node first. This one I'll just initialize this one to head, and second one, sorry, I'll just assign this one to the head, and I'll just assign the second to previous here. This is fine. In this case, let me quickly make use of the while loop. While second here not equal to null, this one. First step here is we have to store the next nodes. So I can write in this way, right? So I'll just give here list node. I'll just make use of the variable temp. So let's make use of the temp one here instead. Temp one, we have already made use of temp or what? I'll just go with temp one itself here. This is fine. So I'll just we have to store the next nodes, right? I'll just give here first dot next comma. Let me make use of the temp2 here. Temp2, let me assign this one to the second dot next, as we have to store the next nodes. I'm just making use of temp1 and temp2. This is fine. So after this one, after the previous step, so here we have to connect the first half node to the second half node. Means 1 we connected to 4, 2 we connected to 3, right? That's what we did here. So 1, this one here. After this one, we reversed when we reversed, we got here. Just give me a second here. 1, 2, 4 and 3. We swapped these two elements, right? 4, 3. So now we have 1, 2, 4 and 3. So now what we need to do? We need to connect the first half node to the second half, right? Second half means second half this one. Second half is this one. First half is this one. We have to connect 1 to 4. We have to connect 2 to 3. That's what we will be doing now, right? That's what we have to implement that one in the form of code, or we have to articulate that one in the form of code. We have to connect first half node to the second half node. Also, we have to connect second half node to the next first half node, right? 1 to 4, 2 to 3. That's what we need to do, right? So I can just write this one in this way. First dot next here. This one, let me assign this one to second, and second dot next here. This one, let me assign this one to the temp one. This is fine. So these two steps are fine. Next, let's move the first pointer and let's move the second pointer as well. So I'll just go with here first equals temp1 and second equals temp2. This is fine. So we have successfully moved the first and second pointer as well. So this is it for the code. 3 steps. First, we went with the edge case, nothing but if the list is empty or has only one node, we don't have to reorder. I mean, yeah, we do not have to reorder here. This case, the first step was, if you remember, we have to find the middle of the linked list using the slow and fast pointers. This we did right here until here. The second step was we have to reverse the second half of the list. First, we split the list into 2, then we reversed or we swapped the elements in the second half, right? This one till here, this one. The final step was, if you remember, we have at any cost we have to merge the two halves. From here it started actually, right? So finally we moved the first pointer and the second pointer, right? So this is it for the code. So simple to understand, right? We went step by step. So this is fine. Let me format the document once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. Let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So we know one thing, the approach that we went with here is 2-pointer and in-place ordering. So the approach that we went with here is 2-pointer and in-place ordering, right? So what would be the overall time complexity here? The overall time complexity would be big of n. Why it is big of n? Because finding the middle, we have first step itself was we have to find the middle node, right? So finding the middle takes big of n, right? Finding the middle first, it takes big of n. And reversing, so in place we change that one, right? We had to reverse this one elements in the second half, right? So in place modification, so we for the reversing it takes big of n. Finding the middle node takes big of n. Reversing also takes big of n. And the final step was merging, that also takes big of n here. So overall time complexity would be obviously big of n in this case, right? So it is quite obviously big of n in this case. So what would be the overall space complexity here? The space complexity would be big of 1, right? We have already discussed this one, you would have guessed that. So we are going with the in place this one, right? In place modification, right? So quite obviously it will be big of 1 because we are making use of only few X pointers, right? And which does not require any extra space basically. So the space complexity would be big of 1 in this case. So the time complexity is big of n, and the space complexity is big of 1 for the code that we have written. I hope the complexities are completely clear, right? So also I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.